Good morning and welcome to this final episode of our MiniStealth tutorial series. We're creating a small roguelike stealth-like game using SpriteKit and GameplayKit. And today we're going to wrap up this series. So first let's go back to what do we have right now. So we have complete games. We have the ability to define maps, add a player and enemies. We have vision and behavior. Both for the player as well as the enemies. We have win and lose conditions. We have multiple levels and you can add your own as much as you want. And we have sound and graphics, at least the basics to show them. What I want to do today is make it a bit more extensible so you can take this as a sort of framework and add more stuff yourself. So what we're going to do is we're going to add a team property to MS Entity, and this way we can more easily add multiple enemy types. And that's in a way pretty simple because we can already vary the vision range of an enemy, and we can also implement its behavior by implementing additional AI components. And as an example, we'll hack together a security camera today, which is more or less an enemy with vision but without any movement. So that's what we'll be doing today. It's probably going to be a short episode, so we'll add a team property to MS Entity and then we'll hack a security camera together. I say we hack it together because this is an example of how to quickly add some functionality more as a prototyping phase, and it's not necessarily the most elegant way of doing it. But I'll try and make sure that it's not too ugly either. So let's dive in and start adding our team property to MS Entity. So let's take our game. And we have our MS Entity file, and we'll start by adding an enum, and we will call this one team, and we'll just have three cases. We have player, we have enemy, and we have neutral. And in addition to the name and heading and position, will also add a team. And for now I will assume that the team is immutable, and when you're initializing a new MS Entity you need to pass in a team. And that's enough to at least implement the team in the MS Entity. This now breaks our world, because when we try and compile we'll get an error that you need to also add the teams here. No problem, we'll add the team player to the player, and for enemies we'll add team enemy. And for the treasure for instance will be something that is neutral. Next, I want to make sure that we're also using these, and we're going to use the teams here in the make enemy called player rules. So here we're simply finding all enemies by filtering on the name enemy, but what if we have additional enemies with different names? So instead of checking for the specific name, we'll filter on the team and we'll say if it's equal to enemy. And we now have a way more flexible system of finding all enemies and checking whether they collide with the player. This should now compile. This should also still run. And this should work more or less the same as it did before. So we can still get caught, we can still capture the treasure, so nothing's changing there. Cool. And let's see, so now let's try and hack a security camera together. For that we need an additional visual to show it in the map. Let's see where our smart asset catalog, and we have our tiles, and I have here an additional tile called security camera.png. We'll put it in tiles. It's not really a camera, but I couldn't quickly find one that's looking exactly like one. So this will have to do. So what do we need for a security camera? Well, I assume a security camera is something that's not moving, but has visibility, but can change its heading. So what we need is a component that will change the heading of the camera, for instance, every turn. So to do so, we'll create a new component, a surveillance camera component. And this will import from GameplayKit, and this will be a final class AI. Surveillance camera GK component, and it will be world updatable, just like all the other components. And this will have a function called update in, because it's a requirement for the protocol, and we'll have a new heading raw value that is equal to the current heading raw value +1. And as with the if the enemies that walk around will change, we change the heading, but we will take the modulus of the number of headings that we know, so we wrap around when we reach the last one. We'll change this into a heading by saying the new heading will be a heading from a raw value. New heading raw value. And this should always work, but if it doesn't, we'll keep the heading we have. And then we'll say the MS entity heading equals the new heading. And what we'll also do is we'll check whether we see the player, just so we can show an event that the camera saw you. So from a gameplay logic point of view, this won't be necessary, because we will check the security cameras in the simple patrol components, but we will trigger an event here by getting the visibility component, and if the visibility component, the tile visibility for the world player position, is visible or false if we can't find it, then we'll add an event to the event list, an alert at the location of the camera. Let's see if we can add the camera to the map. So let's take our first map, and let's say we have a camera right here in the corner. Then we need to make sure that we can tell where a camera spawns. So let's say we have a camera spawn positions array, and if the character equals C, we'll say camera spawn positions, and we'll add coordinates, and we'll put a floor under the coordinate. So now we have access to locations where a camera should spawn. We can go into the world, and we'll say for each camera spawn position in map, camera spawn positions, let a camera be an MS entity named surveillance camera. The team will be enemy. Now let's make the camera neutral, so it you can still stand under it. It will see you, but it won't trigger a loss, because the camera itself by itself can't really catch or hurt you. So we'll say the camera dot add component, and it will need a visibility component. Let's give it a vision range of say 8, and the heading is relevant, and it should also have a surveillance camera component. The owner will be, oh, that doesn't need any additional properties, and the entities that append camera. So now we should see a surveillance camera in the corner. When we run the game and look at the first level, you can see the camera there. Oh, it already spotted us. Look, it's looking around, and when you're in the field of vision, it triggers an event that it saw you, so that's working. But by now it's just triggering the event for itself. It doesn't mean we don't get chased yet. So there's it's obvious that when the camera sees you, it should somehow impact the way enemies behave that are on the level. So for now we'll just assume that when we get spotted, the enemies will go into the pursuing state, because they now know where you are. So what we'll do is, in our patrolling state, where we're looking whether we can transition into the pursuing state, what we'll do is we'll create a new function called, it'll be a private function, can surveillance camera see the player in world, and this will return a boolean. Let's see, let's get all the surveillance cameras from the world that are called surveillance camera. So we need to be very careful that this spelling coincides with the spelling in the world. Let's see. Well, looks good on first glance. Then we'll say for each camera in the surveillance cameras array, if the visibility component of type visibility component, and then if the tile visibility for the world.player.position is visible or false as default, then we'll return true. Otherwise we will return false. And then what we will say is, basically what we want to say is if we can spot the target, or if the surveillance camera can see the player. What I'll do is I'll take a bit of this code and put it into a sort of similar function. So we'll say we'll have a separate function for can we spot the player in world, and this will return a boolean as well. And basically what we'll do is we'll copy paste this code. We will cut and paste this code, but instead of doing this, we'll say return true. And then here we can do is we can say if can we spot the player in world, or can the surveillance camera see the player in the world. Then we can enter the pursuing state and append the event list, and finally return. And this one returns false in all other cases. So now the enemy should also act upon you being seen by the camera. So let's go to the camera again. The camera sees us, and look, there they're coming. So because they saw us. And notice, a bit quick, the enemy's events trigger only once, because once they're in the pursuing state, they keep pursuing you relentlessly and don't react anymore on where exactly you are. So that's it for hacking together a security camera. This one isn't particularly exciting. It loops around 360 degrees. Doesn't make too much sense, but I hope this gives an idea on how easy it is to extend this little game with a bit more behavior. So that's it for now. This is the end of the series. Thank you for being here. If you made it all the way to the end, congratulations, thank you. And I'm interested to see where you take it from here yourself. And as a next project, we will be handling the classic game of columns. So we'll have a bit more animation, perhaps a bit more visual effects, a bit more real-time and less turn-based game. So that should be interesting. Again, we will be using SpriteKit and GameplayKit. So that's all for now. Thanks for watching and have a great day.